Hey y'all, welcome to ZLS 046, and we are doing game dev today, building an RPG with Phaser and Angular. I wanted to start today. I'm hoping we can get through a lot today, so we'll see. We'll see if we can do all this stuff. But before I wanted to get in there, I wanted to really quick go over some of the stuff we did yesterday. Because if you were watching yesterday, we kind of ended up where we weren't getting. Here's our battle scene over here. We were trying to have a little event occur when we're hovering over a unit or when we click on a unit. And yesterday, things weren't working here. And part of that was just me not understanding the Phaser API perfectly well. But we've got it working now. And we've actually got some interesting stuff, I think, going on. Let me see. Something's making my computer slow. Let's see if I can clean it up. There we go. I think that's good. But yeah, let's take a look inside of our battle scene.phaser. So the idea is this file is going to kind of encapsulate our phaser stuff. Anything consuming this would not even so pretty much we just consume this by calling our function, and that's going to return a battle scene. If we look at the battle scene interface, there's nothing phaser specific about it. So far we have a unit being hovered, and we can see that when we hover a unit, we've kind of got their this little HUD element showing up nearby them. Again, not final UI by any means, but just kind of getting things to work. So depending on which unit's being hovered, we'll kind of find out some information about them. And we also have it working. So previously we had it working where we could like click on a unit over here to execute a move. But now we can also click on a unit in the battle here. And it's kind of satisfying to see this happen and like to watch the health go down. So that's kind of cool. but yeah, let's see if we can't figure out how to do some other stuff. I'm going to see real quick if I can't close some stuff down because I feel like I'm going real slow here. Let's kill some extra things real quick. Oh no, don't kill code. Why is it going so slow? I'm not sure. Yeah, I killed code. Let's see. Let's go. Okay. Let me see if I can't figure this out real quick. What's going on? The activity monitor. Something eating up all my RAM? I don't know. Huh. I'm not sure. Maybe try just shutting down some more things. Sorry, y'all. Shut that down. Shut you down. Shut this down. That. Okay, I think we're doing a little better now. Let's try this again. Here we go. Yeah, something about my computer's really not liking today. What is going on? Let's see. Let's try closing some more windows out. That's why I don't know what else we got. Oh, maybe it's all this. Hmm. All right. Well, let's see. Um, let's make a new window for our local host. All right, let's add this back in. I just apologize, y'all. I guess we'll just be going a little slower today. That's okay. Let's go ahead, pop up a terminal here. My goodness. All right. Run nx serve eons. That should get our project working at least. Let's try closing a few more things while this is running. I really don't know what else it could be at this point. Um, yeah, this is taking forever. Let's see. Let's try. Let's try this again. What in the world is taking up all of my CPU? Hmm. Let's see. Oh, maybe that did it. Um, Sorry, y'all, if you're tuning in, having a little bit of technical difficulties at the moment. Don't know why, but my computers decide to be very, very slow all of a sudden. So I'll just work my way through that. And hopefully we'll have some game dev here soon. Let's see. Let's kill some more stuff. Let's see. Any more responsive? Not really. StreamYard's kind of flickering on me now too. I wonder if it's StreamYard. There's some leak going on there. Let me try leaving and coming back to StreamYard. Maybe that'll help. I'm going to throw up some just our intro thing. And yeah, I'll be back. All right. I think we're doing better now. I think there's something in Chrome there's some memory leak. So let's see. Share our screen again. Share it. Here we go. Let's change the background real quick. Much better. All right. Let's see if this works better, y'all. All right. So yeah, we were talking about our battle scene, how we're kind of creating our own little API to encapsulate everything with Phaser for us. So, oh dear, it's doing it again. There's definitely something going on with my StreamYard that appears to be leaking out. Because I was not having these issues prior to StreamYard. Yeah. I don't know. Let's see what we can do here. Yeah, things are just moving so slowly. Is it? I wonder if we inspect. This will give us any insight. Try to move some things around. Excuse me. Alrighty. Excuse me. Well, let's see. See if we can get this to work with us. I think it's getting a little quicker. Yeah, I don't know. Okay. So if we just go to our game, we kind of showed this before, but we've got our Zach over here and our Corbin over here. And we want to just firehammer the Corbin. So we get this kind of semi-satisfying effect, and it's not going to do very well because my computer's trying to take off for some reason. But as soon as we click it, we see his health go down, and everything's kind of feels cool and reactive. And you'll notice all the other Corbins, like on the HUD, had their health go down. So everything's like nice and synced up. But we definitely want to have like our skeletons moving around, and these skeletons actually have an attack animation on them too that we kind of stole from the phaser example. So I'm wanting to have some function to call on our skeleton. That's going to tell him to move just a little bit in front of this other skeleton, and then sort of get a. So the idea is that would return something like a promise or an observable, something to let us know that we've got there. Then we're going to execute a single attack animation, which I think is just a few frames. So I think he just points the swords and like takes a swing, and then we go back. Well, after the swing finishes, we'll need some sort of event to let us know about that that's happened, and then we'll need to go back to our original position. And yeah, so if you think about this, it's going to be like a 1, move over here, 2, strike. And as soon as we strike, we actually want to make sure that we're calling the sort of the execute move. I forget what it's called, but something to execute the move at the point where the attack animation finishes. And that should give us a nice effect where as soon as the swing happens and finishes, we should see Corbin's health go down. And then we'll see the unit move back, and then at the point where our original unit moves back to its original spot, we'll want to call something on our battle engine to let know to keep going, kind of. So yeah, let's see if we can do that. The first thing I wanted to do for this, if we look at our markdown file here, we wanted to expose a move to location method on our skeleton. I'm not exactly sure how we're going to do this, but we'll see what we can do. I think we're going to want to look at our skeleton here. So we're declaring our skeleton as a class here. And I think looking at the code, I'm just kind of inferring some things. But I'm assuming that just by calling this dot something, we can set a property on this object that the class is initializing. So I'm almost wondering if we can do something like this dot, nope, I think this dot move to location. And we'll say is a new function with X and Y. And we'll want this to like set some other properties inside of our closure. If you're thinking about the mental model here. So we'll say something like, when we execute this, we'll say this target location X equals X, and this dot target location Y equals Y. And let's see. Oh man, my computer is just struggling so hard today, y'all. I'm so sorry about this. Yeah, I really don't know what else is going on, but yeah, we'll see. Let's see if we can just kind of move through it. So we're declaring this as a function, saying there's an expression. Oh, okay. Seems kind of silly, but all right. Let's see what's going on here. All right, Prettier decides it's okay. Oof, this is just rough to work with. But let's see. We'll go into our update. So we can see inside of the update, we kind of stole from the phaser example. This is kind of looking, so motion is kind of like our state. Motion is actually, if we see the different motions we can go in. The motion is like the key of our animation kind of dictionary here. So this is like a dictionary of information on how to like kind of parse out our sprite sheet, our start frames, our end frames, and I believe speed is the speed at which you kind of like cycle through them. So we can see we're going to want to use this animation information, and maybe we can adjust the speed a little bit to make things go the way we want. but we definitely want to make it so that this dot motion is not just being fed in from the I guess this is like akin to a constructor here, this initialize function. So what we're going to want to do is we're going to want to kind of take this motion. We're going to say when we call move to location, we'll set this dot motion equals walk. Let's add, oh gosh, this typing is lagging like 5 seconds. All right, let's see what we can do. Let's define a type up here. So we're going to say type animation type equals, and we'll say this could be idle or walk or attack or die or shoot. Is that it? Yeah, that's it. Okay. There we go. Probably, let's put a little note on this to do define in a more common location. There we go. And we'll say here, should be constant. Oops. And we'll say this is a record of animation type to, and well, let's make an interface for, I don't know what to call this. Maybe this is interface sprite animation data. I don't know. I think that'll work. So we'll say start frame number, end frame is a number, speed is a number. Wait for that to finish typing out. So we'll say this is a record of animation type to sprite animation data. The things I do for IntelliSense. That's fair. All right. What's going on with this? Okay, Alexa just being really, really slow. So yeah. All right. But yeah, we're coming along. We're coming along. So inside of our initialize for skeleton here, we'll say this. Well, I'm almost wondering if we want to just go into the. Let me see if I can open up the other example we had looked at. If I go to open recent and Angular phaser example. Oh, I want to open this in a new window. Let's do that. New window. Don't care about the release notes. Get out of here. Angular phaser example. Let's take a look at just the logo sprite. I think this is like akin to what we have for our skeleton here. So we have logo sprite, extends phaser game object sprite. I think we can just copy off of this for now. Let's see if we can like do our skeleton this way. So I'm just going to copy stuff in this file. I think we can kind of remove a lot of it, but let's see if we can do this, because I don't know if I can work with the. I'm just out of my element working with the whatever this phaser.class is. So let's see if we can make a new in our file directory, if that'll ever open up. There it is. As far as it opens up, I close it. So I worry if I clicked it too many times. All right. Oh, no, I did it again. Come on. Oh, my computer's just being brutal with me today. Come on, you can open it up. There you go. All right, let's make a new file in here. And, oops, come on, new file. We're going to call this, we'll call it a unit sprite. Unit sprite phaser ts. Let's see if we can't paste in what we had and just fix some stuff. So we got our phaser. I don't think we're going to want to use the event emitter. I think we'll just use subjects if we want to use something like reactive. In my previous example, though, I was just using the Angular event emitter, which is pretty cool. Pretty cool to just see that dropped in and able to use it. So we'll change the name. We called it logo sprite in the other one. Here we'll call it unit sprite. We're going to kind of want to take, let me close the file system. I feel like the computer's getting faster. I don't want to jinx it, but I feel like we're getting a little faster. So, okay, anyways, we're going to want to take a lot of the stuff that our skeleton exposes, just kind of mirror it over here. Sorry. So let's take like, for example, this animations dictionary. Let's just grab that. We'll put it over here. So these are like, and let's grab our types as well. Where did I declare those types? Yeah, they are. Oh, it's painful. It's painful. All right, there we go. Paste it in. All righty. I think this is actually like, yeah. Yeah, it's definitely not getting any faster. But yeah, we have our animation type. They'll probably look to export this. Yeah, I know. I know you want to prettier everything. Oh, well, that's fine. We'll just export and export. Help prettier out a little bit. There we go. And let's see. We're going to want to, let's remove things from here. We'll kind of like prune stuff out of the scene that we don't need and kind of separate concerns out from the unit and the scene. So we don't need this enums anymore, I don't believe. We'll need our directions. Let's do like this. And we'll say copy directions. Do some typing. We'll say, I don't know, constant directions equals, we can multi-cursor our way to a quick array here, copy and paste and boom. I just need to get rid of this. Say that's as const. And we'll say type direction equals directions string, I think, or no, number. Oh, that works. I don't know. I'll probably have to look this up. Directions refers to value, but is using. Yeah, I think that's what I want. Maybe type of. Yeah. Tio if. Oh, come on. Yeah. All right. I think that worked. If we look at directions now, yep, we get our little thing. And so we're going to want to say interface direction in, let's call it data. Date. Ugh. Yeah, so we got our offset, which is a number. We got our x number. Y is a number. Opposite is a direction. Go and a constant. We'll call this a direction map. Is a record of directions to direction data. I think this would be super helpful in like if like I was trying to set things out to be super isomorphic, but yeah, I don't know. I'm not sold on like art direction yet, but looking at like trying to further separate these things. We have our units, which is a behavior subject of a dictionary of game objects. Actually, I think the way it works is game object is a like the superclass here. And I'm getting a knock at my door. Let me step aside for just a second. And I'll be right back. Let's see. All right, we're back. Sorry about that, y'all. But yeah, we've got our direction map kind of set up here. Looking at the phaser pieces of things. I was changing this to game object as opposed to just a image. I think that's what we were using before. I'm actually not sure what the difference between sprite and image is. Dare I try to look it up? Let's see. Let's try it. Let's see if we can look this up in the docs to figure out the difference between an image and a sprite. Yeah, I wonder what's slowing things down. I really don't know. I don't know. All right, let's try to go into. It's probably in Learn. I think it's. I've been messing around with these for a little bit. Documentation is definitely very thorough, but there's almost like there's too much sometimes. I feel like I have sometimes a hard time going through it. Let's see. API documentation. Where is it? Is this? Oh, okay. Let's grab this, I suppose. Let's copy. Oh my goodness, my computer just copying something. And paste. Alrighty. All right, we're in the documentation. Let's see if we can find sprite. Was this not where we were at before? Okay, yeah, I definitely linked us back. Well, whatever. Whatever. Search is disabled. Okay. Is it disabled over here? Okay, okay, I can use it over here. Let's go to sprite. Let's see if that comes up with anything. Class sprite. I think this must be it. Okay. So this is what we're looking at. Let's see if I can do another window here and just look up image. Image. Another class. Okay. So, both extending the game object. Flip. I think it has exact same extensions here. Okay. Then members of a sprite. I'm wondering if for a sprite, do they have like a better way of animating? Let's see. Yeah, it looks like sprite has an anims member that an image doesn't have. So I think probably because the example we're using is looking at the image. I wonder if the anims thing it's doing is like kind of extending an image to be more sprite-like. I don't know. But an animation controller of the sprite. What's an animation controller? New animation. This might be super helpful if this can do some of our stuff for us. Yes, I think it will be. It's playing. So let's see. Is there a way to like enumerate? Okay, current animation. What is this saying? The current animation loaded into the animation controller. How do I like give a dictionary of different methods? New animation. Animation is a game parent too. This is where like object-oriented programming, I think, falls down. I've definitely lost like mental scope to all the different classes being extended here. Let's see. Play. Start animation. It's private. Let's take a look at that. Extracted from play. Okay. Let's play. Play is an animation that has the animation component, such as a sprite. Okay, that sounds good. Animations are stored in the global animation manager. Oh. So the key is a string-based key of the animation to play inside the animation manager. What is an animation manager? Let's see. Or an animation instance. Okay, so how do I like put multiple different animations on my sprite? That's kind of the question. So I think I can just, if I can do this right, we can just call play on the animation with the key when we want to switch it. And what is load? Load an animation into this component. Progress, get current key, Turns the key of the animation currently loaded. Okay. Chain. Is that a key array? Or is that optional? You can pass in a key. I think that's optional. You can pass a key. Sets an animation to be played immediately after the current one completes. Okay, that could be helpful. Maybe. So how do I'm still kind of stuck. How do I add more animations? So current frame. Let's see. Animation manager. Let's take a look at what the animation manager is doing here. Animation manager. Go. Animations are managed by the global application manager. This is a singleton class for creating and delivering animations. Okay, so it's like unlike plugins, but not the scene. Okay. Okay. I would expect this would be, we'd want this for each sprite. It seems interesting that there's an animation thing here. An event emitter. That's cool. All right. Adding a key and an animation. Okay. Key under which. Huh. Okay. These are starting to make sense. Our listener. It'd be nice if we knew what the different events were. And that's probably somewhere in the documentation, but figure it out. Emit calls each of the listeners. Okay. Access. Excuse me again. I don't know. Maybe for now, I'll just have things rather than extend a sprite. Maybe I could just have things extend an image for now, and just kind of play off of the way things are going, because I'm definitely getting lost in the documentation, but it's okay. So let's see. We've got our unit.sprite.phaser. Let's go back to where we're declaring the. Oh, come on, computer. You can't even scroll. Oh my goodness. All right, let's see. So here we're saying it extends a sprite. Let's make it extend an image. Image. There we go. I don't think we'll need a lot of this stuff. We should have a unit ID. Probably texture name. Okay. Frame. We need a frame? Yes, we do. We'll say public unit ID string. Go. Get rid of this one over here. Get rid of some of these. We'll call super. Get rid of most of this stuff. Pointer over. Cool. Just kind of going over where different stuff's happening. All right. We're starting to clean this up a little bit. Let's see, what does it like about this? Cannot follow an optional. Okay. Let's try passing in 0 there. Figure out where this takes us. Blowing up, we don't really want to blow up, so we can just erase this. All right, that's really clean. Now we'll want to this. Yeah. All right, we'll want to take a look at what we're actually doing inside the skeleton and start moving this stuff over. Sorry for the technical difficulties, folks. Yeah, we're definitely not going to get very far today. Definitely not as far as I had hoped, but I'll definitely post some updates if we can get any further between streams here. But yeah, let's see. Let's prune some more as we're going through this. So create battle scene. All of this looks proper. That we'll call that to actually make the thing. This will add a unit, and we'll say, actually, let's say this is actually a dictionary. And we'll call this of our unit sprite. Sprite. So unit sprite. Oh. All right. Function preload. So I want to do most of this. Okay, does the game object have a preload? I feel like it does. Maybe it doesn't. Yeah, that makes sense. We probably have to preload a sprite sheet early. So let's leave that here. And we'll say on function create. Okay, so let's pass in. We could say just initialize. Function. Well, I don't know. We'll say current animation. We'll want this to be an animation type. Animation type. We'll say maybe initially this is title. I think we probably want to give it like some sort of instruction. So we'll say interface instruction. And this would be, I don't know. It's probably like, let's make it a type actually. Type, and we'll call this a unit sprite instruction. And we'll say type is walk and destination is, we'll say x is a number and y is a number. So that's one possibility for instruction. Another possibility would be type attack. I don't think we need any additional information there. And maybe a direction. Let's say facing direction, and we'll say is a direction type attack and a facing direction. We can have another one that would just be, let's call one for idle, type idle, facing direction. All right. I think we're getting closer. So the idea is we'll kind of send out a direction or a unit sprite instruction. So let's just see if we can add that here. So we'll add a method on here that's something like set perform instruction. We'll say takes in an instruction, which is a unit sprite instruction. We won't define what it returns yet. I think probably this is where we'll want to return like the observable at some point, either observable or a promise. But we'll say if maybe switch on this actually. Switch on instruction dot type. We'll say case walk. This dot current animation equals walk. We'll say let's have an optional destination here. So this would be an X, which is a number, and a Y, which is a number, or it would be undefined. Undefined. Go. So in the case of walk, we'll say this destination equals instruction dot destination. Go. And yeah, let's add a facing direction here. Facing direction. Facing direction equals instruction. Probably don't need to switch off the type, actually, I'm realizing here. I think we can probably just do can just do like so. Current animation equals instruction dot current type. And we can just do what doesn't I like about this? I guess that it can't. Does not exist. Oh, okay. Can I not do like does exist? All right, we'll say to instruction as Destination. The same instruction as any. That gets us there. All right. So now we probably want this to return a promise of when it's over. But I'm not sure how that would work. Either a promise or an observable. Observable might be better, actually. Man, StreamYard's really messing up for me. It's just flashing all over. I'm just because of all the technical difficulties, I think I'm just going to end it here. I don't think there's many people watching right now, anyways. So, yeah, we'll see if we can pick this up again later and see what's going on with StreamYard. So, yeah, hopefully we'll have a better time tomorrow. Tomorrow we've got Josh Van Allen coming by. We're just going to have a just chatting episode tomorrow, just chilling with him. And oh no, I'm sorry, Josh is on Thursday. Caitlin's tomorrow, so looking forward to having Caitlin on. Should be fun. So looking forward to that, and hope we all have a good one. And I'll see you tomorrow. Bye now.